Okay, hypothesis testing. Today we are going to begin the first of our many tests that we're going to learn. So everything we talked about yesterday was a setup for the whole rest of the year. Everything we do the rest of the year is a hypothesis testing scenario, period. But I'm not kidding. Well, I wasn't kidding about the rest of the crap either. Okay. Sometimes I maybe tried to oversell it, but that was not an oversell yesterday. Literally, the rest of the year is hypothesis testing, period. Literally. And I'm not saying that because I'm making fun of you. It's literally true. Okay. Now, anywho, so today we're going to talk about the z-test. Now, this is a test for means, obviously. Because what is the z about? It's find x bar minus mu and all that business, yes? Now, here's how this is going to work. Now, why do we use a z instead of a t? Same reason we always have. When n is what? Bigger than or equal to? 30.
Why 30?
Why 30? That is a great question. That is a fabulous question. Hey, look, here's the z distribution, yes? Isn't it pretty? The t distribution it looks like this, right? But as t approaches 30, they become virtually indistinguishable. Right around 30. And so as a result, why would you screw around the whole degrees of freedom and all that other garbage if, when you're right around 30, you could just use the z instead? So that's the game. Okay. In fact, they're never quite the same. We say they're asymptotically the same. So as t goes to infinity, they're the same. But around 30, they're pretty much indistinguishable at that point. Okay. Does that make sense? Well, you asked me. I'm just telling you. Don't huff and puff at me, lady. Anywho, there it is. Okay. So watch me spin a yarn for you. Abby believes. By the way, is Abby free to believe whatever she wants to believe? Yeah. Now, why might she feel this way? Mr. Grimm, she's been doing this for a long time, and she just knows. She has a feeling. Women's intuition. She has a lot of experience. I don't know what it is, but she has a gut feeling. She believes the average number of times Mr. Grimm says literally per day has increased. You see that?
Slash.
Per day. What?
You put slash.
Where did I write? Oh. I got it. Sorry. You're right. Slash per day. Per. Yeah, it's dumb. Thank you. Thank you. Nice. Now, without hearing anything else from the story, if a person were to set this test up, and I'll skip down the page ways because I'm going to finish my story in a minute, okay? I feel like I heard this. I heard mu is greater than something. That's what I heard. Didn't you hear that? That's what I heard, right? I heard it has increased. It used to be something. It's bigger now. And, of course, the opposite of that is this fella here. Now, I don't know what the numbers are yet, and I'm going to figure that out in a minute when I finish telling my story. Okay? But for right now, that's what it is. So, she finishes filling this in for us. It used to be, because she kept track of this, used to be he would say it 33 times per day. Mm-hmm. So down here, what I'm hearing is this bit right here. Right? Ta-da! But she says it's bigger than 33 now. Are you hearing this from the story? So what does she do to test this theory of hers, Krista? Krista, this is statistics after all. What do we always do when we want to know something we don't know something about? Well, before we do that, we take a sample. That's right. So she takes a sample. She takes a sample of what? Of what? Of days, yes? Of days. How many days?
5.
Really? It's a t-test, so I feel like
Oh. Well, you just said it was a
35.
test.
That's a z-test. I'm sorry.
35 days.
That's what I was going with. It's a z-test, so I feel like it should be more than 30, right? 30 or more?
35.
Okay, so we'll go with 35 just because someone told me to. A sample of 35 days. Now, what will she find out about that? Well, she's going to find an average, yes? Now, she happened to find that X bar, which is the sample average, was 37 times per day that Mr. Groom said literally, which seems like a lot. And a standard deviation of 6.9. Because why not? So now listen carefully. At alpha equals 0.05, is Abby right? Okay. Now just nice and slow, nice and easy. So we have our little hypotheses set up right down here. It's very straightforward. Now let's draw a picture, shall we? Whee! Is this an upper or a lower tailed test? How do you know this? Because no, you're totally right. You're totally right. Watch. Because always look at the alternative hypothesis, and it's pointing to the upper side, yes? So over here, you're going to make a little doohoo like so, and put 0.05 over here. What? They're at the magic Pez dispenser, right? Right out of the magic Pez dispenser. Now, friends, OMG gosh. Could we find this cutoff score? Is there a way to do that? How? Do it now. How? How do I find this z value that corresponds with 0.05? What do I do? Inverse normal. That's right. Do it now with me. Inverse normal of 0.95. That's it. Because it's a z-score. That's all I got to put in. And it comes out to be 1.644, yes?
That's in Excel, right? The inverse normal?
It's in Excel, it's in Sheets, it's in the computer calculator. It's all the same basic premise, yes? No, it is. It's all literally the same. Okay? Okay? Is that what you get? Negative 1, you get positive 1.6. If you got negative, you put in 0.05, didn't you? Right? So drop the negative, put it on the other side because it's all symmetric. Don't beat yourself up about it. Just make it positive. What now? M's what?
I don't think it's
It's equals
It's
norm S inverse on spreadsheets. Norm S inverse. Thank you. Good call. Good call. But again, we've done all that part. That's not terribly brand new, yes? All right, let's make a z-score, shall we? So remember, our z-score is x bar minus mu over s or sigma, whichever you have, which will never be sigma. So it'll be this thing right here. By the way, that is the central limit theorem, yes? Regardless of how it's distributed, it's always the x bars are normal, right? So what is my x bar? It's 37 minus 33, right? Over 6.9 over the square root of 35. What does that come out to be? It's going to come out to be like 4-ish. It's 4-ish. Yeah? 4.2? Oh, okay. What? I didn't say you're wrong. I said 4-ish.
Oh, I said 3.43.
Well, I'm just using my head, so there's not much up there. It's good for a paperweight. That's a lot of weight. There's nothing in it. What do you got? Let's see. 3.4. Okay, listen, it's not that I don't believe you, Abs. I'm just asking. Make sure everyone's on the same page with us. Yes? 3.42. It's not 2.4. I'm quite sure it's not 2.4. Is it 3.4? What do you get? 3.4, what did you get? 3.42. Okay, good. Yay. Now, friends, where is that at? That is out here, yes? That's weird, yes? That is weird, but it's only weird if what is true. It's only weird if this is true, right? But in fact, what's more likely? That's wrong. Yes? It's more likely that that's wrong, and the mean is closer to what? The mean is probably actually closer to 37, yes? And what we saw was something what we'd expect to see, and our assumption was just wrong, yes? So our decision here is to do this. We're going to reject H naught. That's a fact. Right? Now, the number of times Mr. Groom says literally has increased, big word here, what is it? Significantly. Mm-hmm. All right. Now, the question asked, is Abby right? What did Abby say in the original problem? It has increased. So is Abby right? Yes. But remember, the game gets played whether Abby bets on it or not, yes? So play the game first, and at the end, address whether Abby's right or full of beans or whatever, okay? We'll address that later. Okay? Now, Miranda, what we just did here is what is referred to as the classical method. The classical method. And that is the idea that you're going to find a so-called cutoff score. Okay? And then you're going to find a z. So we did a z was 4.3 or whatever it was. We call this our test statistic. Whatever, 3.4. Did I say 4? What is it, 3.4?
3.4.
Whatever. Not important. But this guy here is our test statistic. Now here's the deal. I don't like to get all mathy with it. Watch carefully. If the test statistic is further out in the tails, we reject, because that's weird. Okay, if it's out here, we reject. If it's in here, we fail to reject. Okay? Mr. Broom, I have a question. What if it was a lower tail test? Then your cutoff score would be right here. Right? And if your test statistic, if your test stat was out here, what would it be? I'd fail to reject. That's normal. That's where I would expect it to be. But if it was out here in the tails, I would reject, because that's weird. Yes, dear. What's that?
Everything's weird.
No, so this is fail to reject here.
Oh,
This is reject out here. So if you're in the tails, you're going to reject, because that's weird. If you're anywhere but the tails, we're going to fail to reject. Yes. We do not accept. Remember, OJ got off. It doesn't mean we're like, oh, well, cool, he's innocent. No, he got off. They did a crappy job of proving him not innocent. Right? Do not use the word accept. We don't accept anything. We fail to reject it or we reject it. That's all we can do. Okay. What?
I'm a little bit confused, like how you tell if something's upper tail or lower tail.
Oh, it's right here, dear. It is literally right here. Oh, no, but no, that's weird. This is not what I wanted, but we'll go with it. Always look at the alternative hypotheses. If it's pointing this way, it's upper tail. If it's pointing that way, it's lower tail. If it's not equals, it's two tails, baby.
Is that always going to be?
Always. Every single time. Take it to the bank. All right, here we go. So let's spin another little yarn. Jacob Haynes believes. Now I'm going to go with feels. Feels. It's not important. I'm just telling the story. This is a lot of fluffy bluffiness. Feels the number of times should we do per day? Yeah, per day, sure. That his mom yells at him has changed. I was going to say Lily, but then I figured that'd get me in trouble. So I'm not going to do that. Okay. Now, I don't know his mom, so it's fine. But I know Lily, and that's not a bueno. Now, so I've heard the initial portion of this business right here, yes? Now, what did you hear? I heard it has changed, yes? Is that better or worse, Anna? It's different. So here it is, sister. It used to be equal to, and now it ain't. You see this? This is a two-tailed test. Has changed. Is huge. One of the many keywords, not the only one, many keywords for two-tailed tests. Could go this way or that way. Now, let's go back and finish the story, shall we? Jacob's mom's a very nice lady. Now, no, I don't know. Watch, I'm just taking that. No, I don't even know. It used to be, now listen, we have to have some sort of it used to be deal. It used to be, I don't know, 10 times a day. So he takes a sample of, always have to take a sample, of 50 days. And he finds that the average is now 7.31. With a standard deviation of, I don't know, 8. Because why not? I don't know. And then he's going to test this at alpha equals 0.05. I don't know. So what goes down here in the hypotheses? What's that? It's 10. Because that's what it used to be. Okay? That is what it used to be. Yes, dear?
What was the standard? What's the standard?
It's just 8.
Just 8.
With a decimal behind it. Because that's the end of the, it's a period because that's the end of the sentence. Yeah. I can see where you'd be weirded out by that. But yeah, it's just the end of the sentence. All right, now we good? That make sense? Now let's say two-tailed test, allow me to draw the picture. If you're not drawing the picture, you're doing it wrong in my estimation. You should always draw the picture. It literally takes 2 seconds. It doesn't even have to be pretty. Just draw it. Hey, it's 2 tails, baby. How much total are we putting out in the tails? 0.05. So how much is going in each tail? That's correct. So it's perfectly 100% symmetrical. So on your computer, phone, what have you, inverse normal, normal S, inverse whatever, of 0.025, yes? And it's 1.96, and negative and positive, yes? Those will be our critical values or our cutoff scores. Yes, dear?
So in the last problem, it was 0.05 alpha 2.
But it was all in one tail.
Oh, okay.
Here we're splitting it.
Okay.
Nice. Nice. By the way, the book, if you're a person who reads the book, which let's face it, Naomi does. I don't know. No. Yeah, but whatever. Listen, you will see this terminology pop up from time to time. What is this? It is the Z that corresponds to half of your alpha. Yes? That's how the big kids say it. So if you see this in your book, don't freak out about it. It's literally just taking the alpha, dividing it by 2, and doing the Z-score for those guys. Okay? That's all. Anyway, I kid you not, because most people don't read the book. They're just like, yeah, whatever, it's a book, it's got problems in it, right? Right? Am I right, Pelham? You don't read it, do you? I didn't think so. So you're happily ignorant that it says that in there, but some people might see that and go, what is this about? Okay. Now, let's go back here. Oh, hey, we need to make a test statistic. So Z equals 7.31 minus 10 over 8 over the square root 50. Good night. I did another reject. Oh, well, whatever. Time to shave the beard. That's past time. I've just been too lazy. I'm assuming it's my own hair. It's just, whatever. What is it? Negative what?
2.37.
Now, where is that located?
Outside.
It's out in Freakville. Again, freaky, but only if what's true. If H naught is true. In fact, I don't think it's 10. I think it's closer to where? It's probably closer to 7.3. Right? I think it's closer to that. Now, I don't know what it is, but I do know this, friends. We're going to reject H naught. And what does that say? It says the mean number of times his mom yells. She yells per day has changed significantly. Now, it's important to note, we cannot say it's gotten less. Because we were asked about changing, and by God, we can say it's changed. Cannot really truly say it's decreased, but yeah, we have a pretty good idea. Now, normally in a situation, good God, I got another one in there.
That's disgusting.
That's time to shave. Now, it's funny because sometimes I eat lunch with Herdrick, while I'm standing there with him, and like he has that big bushy beard and stuff, and like it's like, ah. Anyway, but anyways, as I was saying this, normally Jacob would have a clue that his mom is being, less irritable or what have you. So he might in the future say, I think it's decreased. Yeah, but whatever, yeah. No, maybe? You good? It's not hard. All right, let's try another one here. You try this one. I'm going to wander around and make you feel uncomfortable. After I get this hair out of my mouth. I'm going to go home right now. All right. Naomi. Right. Naomi feels the number of times she is called on in class. Now I'm just going to say in class in general, not just Mr. Grimm's class, has increased over the years. You can fill in the blanks from that. Why is that, Mr. Groom? Is it because she's coming out of her shell? Is it because teachers are making a point to call on the quiet kids, punishing them for being quiet? I don't know. I just think it's funny when she laughs and giggles like that, so that's the only reason I do it. Yeah, same thing I make a big deal about Josie, because she squeals when I make fun of her. Why are you doing that? Yeah, no. I here have increased. Upper or lower town? Upper town. This is what I'm hearing. Do you see this? Hmm? Anyway, I'm going to finish it from here. So I'm just going to let you go from that. Used to be 2 times per day. Over the last 40 days, she has an average of 3.2 per day with standard deviation of 3.1 because I feel like it, because I can. So at alpha equals 0.1, is she correct? So try that while I walk around to make you feel uncomfortable. And take a minute. Oh. Where is it on that distribution? So you need to say it. I'm going to read the activity.
Used to be 2
So.
times.
Hello. Calm down.
How we doing? How we doing? Doing all right? Doing good? Doing good? Not bad? Feel like freakish. Weird. Weird.
Wait.
Because some people are quiet as they usually have to go. People think to say, and then all the correct you have to do this. Let's count. All right, what do we got? Wait, I'm not done yet, Mr. Groom. What's taking you so long? I'm going to start filling in the blanks we know. All right, Emmy, 1.28. True? A little z-score here, a little x-bar action minus mu. Sx over the square root of n, whatever. And this came out to be 2.4 something. Webs. It's out here. Which would be weird. But it would only be weird if what? H naught's true, so my decision is to reject H naught. And what are we saying? Naomi. Well, Naomi's right. Of course, let's make sure we get that right. Bask in that for a minute. She's right. She does get called on. Significantly more often. Now, Mr. Graham, I didn't quite write it like that. I wrote H naught, reject H naught, and then I said something like, Naomi's right. Is that okay? Well, yeah, I mean, I guess. There's lots of ways to phrase it. I'm looking for this, and I'm looking for kind of a something over here that kind of addresses what the question asked about. Okay? There's lots of ways to say that, Linz. Lots of ways. Now, this is, again, the so-called classical method. It's how it's always been done. Now, there is another method that we're going to spend most of our time dealing with. But on every test from now on, we will introduce it by the classical method. Maybe we'll make a t-score? Yes, later on we'll make a t-score, yeah. How about that? And we'll do like an inverse t? Later on we'll do a chi-square and a chi-square inverse and all that. Well, you will, by God. When I'm done with you, you will get it. Mr. Groom, an F and an F inverse? I don't even know what an F is. You will. Relax. Yes, all the way through. But we will always identify it that way to start with. Then, we will always then move on to the second part, which is the more important new way, which is called the p-value method. Now, here's the game. If p is less than alpha, you're going to reject H naught. That is the rule. We're going to talk about p-value in a jiffy. Okay. But a minute ago, we got a z of, what was it, 2.45 a minute ago? Is that right? And the picture looked like this. Here's 1.28. By the way, what is the probability that you are bigger than 1.28? Duh, it's 0.05 or 0.1 because that's how you found it, huh? Am I right? Am I right? That's how you found it. This thing right here is alpha. And if you were going to do this on your spreadsheet or whatever, you would do normal CDF or norm S dist or however you're doing it on your deal, right? And then the calculator would be normal CDF 1.28 to infinity. And it would come out to be 0.1. On the spreadsheet, it would be 1 minus norm S dist of 1.28, and it also would come out to be 0.1, correct? That's how you would. That's what it is. It's 10% from here out. Okay? But 2.45 is out here somewhere. Yes? From here out, is it going to be more or less probability? Less, obviously. And so to do that, to find the p-value, we'll do exactly the same thing. We'll do normal CDF, 2.45 to infinity, or 1 minus norm S dist from 2.45, like that. And what does that come out to be? 0.0 something. .007. OMG gosh. Okay? This p-value, it means something. Very important. P-value, and by God, this is on the next test, Miranda. You want to jot this down. P-value is the probability I saw what I saw given H naught is true. So this is what we talked about yesterday with cards, right? We got down to like 0.000 chance of it happening like that many reds in a row. No, sorry. BS. I don't buy it. Okay? So notice because 0.007 is less than 0.1, our decision is to reject H naught. Right? It's just the other way of doing it. Notice how, what if you had 1.29 you'd reject, yes? Right? But just barely? But if you had like a 15 z-score, you'd reject the bejesus out of it? This is similar to saying, well, we won. What'd you win by? We won by 70 points. So you didn't just win, you killed them. Okay, cool. We won by a point in overtime, third overtime, barely. Okay, whatever, right? Then, yeah, you barely squeaked over the hump, okay? The nice thing about a p-value, it kind of gives you an idea of how much you reject by, okay? Not very hard to do. Now, Mr. Green, what if it's a lower-tailed test? It's a great question. If it was a lower-tailed test, like, say, negative 1.28, hey, thanks. She's not here. And why would that didn't even make sense? She had surgery, so why was she? I don't know. I just work here. Now, what if you got a z of negative 2.45? Ask you. What if you got a z of negative 2.45? Well, Mr. Green, that'd be out here, yes? But how would I find the difference this time? Notice it's on the lower end, right? So I would do, on my calculator, I would do this. Alpha, you know, of course, is equal to norm ol CDF from negative infinity to negative 2.45, which is still equal to 0.1, right? That's where that came from, right? And of course, on your computer, it's going to be just norm S dist negative 2.45, right? Not 2.45. I'm sorry. Sorry. No wonder he's looking at me funny. God dang it. 1.28, right? 1.28. There we go. Right? 0.1. Okay? Because it's a lower tail, I don't have to do 1 minus. Yes? We've already talked about this a little bit, but we don't have to do 1 minus for these guys. So what would the p-value look like? Exactly the same. So p-value would be normal CDF from negative E99 to negative 2.45, or norm S dist negative 2.45. In either case, what do you get? 0.007 again. Because it's perfectly symmetrical, yes? So since I chose the same one on both sides, right? Nice. Kaylee, that make sense?
Wait, the 0.007, is it negative? Can you do that?
No, it's a probability. It's a probability. Probability is always positive. Okay? All right, so that's cool. I want to do a two-tailer just for fun, shall we? Okay. But this time I'm going to write a story about this one just for fun. Because I like stories. Blah, 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 Mr. Hernley. Thinks, believes, whatever. Me. Actually, I'm going to say Mr. Groom. Mr. Groom feels, thinks that the length of announcements has changed. So help me God, if I get another singing telegram this period, have changed. Listen carefully. It used to be, just a minute before you start that racket there, just a second. I appreciate it, it's great. Just a second, hold up. It used to be like 5.7 minutes. All right, let me just pause. Thanks for coming. No. Yeah, we're here. You gotta turn the light on, Jacob. What? No, just a minute. I'll see you later. not pissed. I just feel uncomfortable. I'm not pissed. I just feel uncomfortable. All right. Now, all right. So listen. I hear two-tailed test. Do you hear it? You hear it? It used to be. I feel like it's changed. Okay. Set. I recorded back on you. Thank you so much. Keeping me honest. All right. This is what I hear. No, I'm not pissed. It just feels weird. I don't know. It's awkward.
It's like when people say happy birthday.
Except it kept going. And talking about me being so charming and weird. And you got the wrong room. Go away. Wait. Lindsay said it's Mr. Patterson that's the charming one. He's so much nicer than you, Mr. Groom.
I think it's kind of funny because it's like embracing, like.
It's true, but it's fine. But it's like, wow, it's dagger to my heart. Yeah, okay. Shh. All right, let's finish this up. We're running out of time. So, he samples. Obviously, he's got to sample something. Otherwise, what's a waste of this? So, he samples, let's say, 30 days. And he finds that the average is 6.1. With a standard deviation of, this is X bar, thank you. And X bar SX of, like, I don't know, 10. Let's make it big. I'd like to fail to reject one of these times. It'd be kind of nice. I'm getting tired of rejecting the crap out of everything. By the way, it's nice that I'm going to be the one that's wrong because I'm used to that, right? Whatevs. So, alpha, let's just do alpha as 0.1 just for a good time. No, okay. So, it's a two-tailed test, so I got to split it up. Put an 0.5 in each tail. So it's going to be 1.645 and positive 1.645, right? You should check me. That's right, though. Okay. Thank you. Well, just make sure. You just never know. Okay? Because people are like, oh, yeah. How'd you do that? What? Yeah, so it's good practice. Hey, I need a z-score here. So z equals 5.7 minus 6.1. Oops, I did it backwards, didn't I? 6.1 minus 5.7. Does it matter which way you subtract them? On a two-tail, not so much. But on anybody else, it totes does. Over 10 over the square root of 30. A bunch of sick people in here. Anyway, what does that come out to be? Something like very small, but positive. What is it? You're not sick, it's just cigarettes? What are you saying? What? 0.22. What? I got a z-score of 0.22? That's out here. Well, that's exactly where I would expect it to be if what's true? If H naught's true. So fail to reject H naught, which means what? Mr. Groom's an idiot. Mr. Groom is wrong again. You don't have to put the again in there. I will. Okay. Is wrong. They have not changed. They have not changed in length or something to this effect. Again, big word, significantly. Right? Now, Alyssa, you're thinking, Mr. Groom, could you do p-value for this kind too? I would love to, but watch carefully. Watch Mr. Groom do this carefully. Suppose I did normal CDF on my calculator, and I went from negative infinity to negative 1.64. You're expecting that to be 0.1, aren't you? But you'd be wrong. It's only half of alpha, isn't it? Yes? You see this? Right? Which is equal to, half of alpha. So what would you have to do with this thing? You'd have to times the whole shoot match by 2, yes? Well, the same thing is going to have to be said when we find the actual p-value as well. So watch Mr. Groom find the p-value. Mr. Groom will do the normal CDF of 0.22 to E99. What does that come out to be? For the rest of us, we're going to do 1 minus normal S dist, whatever, of 0.22. What is it? 0.41. I'll buy that for a nickel. But that is half of the p-value. This is equal to p-value over 2. That's half of it. So I would like to know the whole shebang, so I'm going to times it by 2. So that means my p-value is 0.82. In other words, there's an 82% chance I saw that. if H naught is true. That happens literally every day, so I'm going to fail to reject H naught. Again, 0.82 is bigger than 0.1, so because P is bigger than or equal to alpha, my decision is to fail to reject H naught. That's it. Not hard at all. Now, tomorrow. Yes, tomorrow. I did it right on accident. Before tomorrow, it'd be really cool if you go home to the first section of your homework and come back with a few questions. Now, so 8.1. Now, I would say this, that on this page 422 one, this 422 is the one I'm talking about. Notice how it says, do 7, 8, and 9, the classical method. The rest of them I want you to do p-value one. Some of you, the good students among us, are like, my God, I'm going to do it both ways just to practice. On the test, I guarantee I asked you to do one or two randomly. Here, do classical method. And another one, I'll say, here, do these ones with p-values. Other ones, I'll just say, go, test it, whatever. And you'll say, I'm going to do it both ways. I'm going to do it one way. I'm going to do it this way. I don't care. You should be comfortable both ways. Now, I will say this. TI 80 whatever users and 90 whatever else calculator users, tomorrow I will show you there's another step to this that you can do differently slightly. Okay? And that's Q, but I still need you to understand where that's coming from. What? Yeah. Seriously, I wasn't mad. I was just uncomfortable.
Thank you.